Hello. Hello and welcome students. My name is Dr. Vibha Shrivastava. Today I am going to discuss about electron affinity. So what is electron affinity? It is the energy change or released that occurs when a gaseous atom gains an electron. For most atoms, this is a negative quantity or energy is released. Noble gases have a positive electron affinity, means it actually requires input of energy, means the positive value of electron affinity to add another electron. In general, electron affinity increases from left to right across the period. In general, electron affinity decreases from top to bottom down a group like this. Here, electron affinity increases across the period and electron affinity value decreases from top to bottom down a group. Electron affinity increases, becomes more negative left to right across the period. This is due to increasing effective nuclear charge, which more readily pulls these new electrons in. Okay. Let's talk about first electron affinity. Why first electron affinity increases from left to right across a period? Consider oxygen and fluorine atom. When we add an electron like this, then we can see energy released is higher in fluorine. Here we can see energy release is higher in fluorine than that of oxygen. As we have seen, electron in the same shell, like this, electrons are adding in the same shell. Here we can see one electron is added here and one electron is added here. Means distance from the nucleus for new electron from the nucleus is the same. From the nucleus is same, and we have same shielding effect since we two electron for both, and electron repulsion is the same for both cases, and effective nuclear charge is measurable. We have 9 for fluorine and 8 for oxygen. Now, electron affinity decreases from top to bottom down a group. Now, let us consider first electron affinity for lithium and sodium. Sodium is right below to lithium. When we add an electron to each atom, we can say when we add an electron to each atom, then we can see energy released is higher in lithium. Here, energy released in higher in lithium than that of sodium. Reason for this is electrons are added to same energy levels and they don't have same distance from the nucleus, and also electron added in lithium is shielded by only 2 electrons. This added electron shielded by only these 2 electrons, and in sodium added electron or new added electron is shielded by 10 electrons. So, electron repulsion in the same in both cases, and effective nuclear charge doesn't affect more in these cases. So we can say this is due to the balance between increasing atomic radii and decreasing electron repulsion. Thank you.